So this video is on integrated 2, and this is the tangent and cotangent homework. So on this first one, what we are doing is we are trying to find just the pieces, okay, not graphing it. So for this, the amplitude is going to be 2. When they say flip, you're paying attention to whether your amplitude had a negative in front of it being flipped. So this is no. Vertical shift is -3. Your period, normal period is pi. It's pi divided by your b, which is 1/2, and that is actually going to be 2 pi. And then your phase shift is going to be none because we don't have anything added or subtracting. For number 2, this is a cotangent. My amplitude is going to be 4/3. This is also going to be no for a flip. My vertical shift is going to be a +1. My period is going to be pi divided by 4. And then my phase shift is going to be pi halves because that's what makes this 0. On number 3, my amplitude is going to be 5. When they say flip, yes, because it has a negative in front of it. Vertical shift, none. Period is going to be pi divided by 3. So this 3 in front of my x is actually my b. Now, when I'm doing my phase shift, I want to ask what is happening here. So for that, I am going to set that equal to 0. And I'm going to end up getting a negative pi-3 when I do that math. So that's my phase shift, is a negative pi-3. On number 4, when we start graphing. So this one, I am going to have a vertical shift at a height of 2. I'm just going to draw that in here. So that's going to be that height of 2. I am going to be going 1 above that and 1 below that. Okay. I'm just going to make these a little transparent. Okay. And for my tangent, when I am doing it, if I'm thinking about my unit circle, and tangent is y over x, where is my cosine? 0. So it's 0 here and here. So normally I'm going to go from negative pi halves to positive pi halves. And then I'm going to be plotting my -1, my 0, my 1. So in this situation, my period has not changed. So I am going to have my asymptote here, at negative pi halves, I apologize, which this is going to be negative pi halves here. And at positive pi halves. I'm just going to extend this up a little bit. And the equations for those, x is going to equal negative pi halves, and x is going to equal positive pi halves. And then I am going to plot my points. So I am going to be starting at my -1, but really that's going to be on the lower one. That's like my 0. That is like my +1. And then I'm going to draw my graph. I'm just going to make it a little thinner or more transparent for us to kind of see through. There you go. For number 5, this one is a cotangent. So when I am thinking about cotangent, this is where I'm thinking about x over y. So where is my y? 0, which is here and here. And so I am going to be going from 0 to pi. I am going to be plotting my 1, my 0, my -1. Okay. So in this case, I have not changed my period. I have not shifted anything. So I am going to have an asymptote here on the y-axis, and I'm going to have an asymptote here at pi. And for this one, I have a vertical shift down to -3. And my amplitude is 2, so I'm going to be going 2 above and 2 below. I'm just going to make those a little more transparent. Okay. See if I get my green one too. Okay, so now for this, when I'm graphing this, I am going to be starting at my 1, 0, and then -1. So I'm going to come over here. My 1 is really going to be up here. My 0 is going to be here. And my -1 would be here. And this is going to be my cotangent. For number 6, okay, again, I'm focusing on this. I'm just going to copy this. Okay. So I want to think about where my tangent is going to be undefined. It's going to be undefined at -pi-halves and pi-halves. So for this, if I want to figure out where my asymptotes are going to be, I know that they should normally be at -pi-halves. So I'm going to start with taking my 1/2. Let me just move this over. My 1/2 x, setting it equal to a -pi-halves, which means I'm basically going to multiply both sides by 2. So I'm going to be at -pi. And if I take the same thing but set equal to +pi-halves, I'm going to end up at a +pi. So I am going to have an asymptote here at -pi. And I'm going to have an asymptote here at +pi. So that is going to be x equal -pi and x equal +pi. And I think I forgot to write it on this one here. So this was x equals 0 and x equal pi. Okay. Okay. So for this one here, what I am going to do is I'm going to be looking at my vertical shift. My vertical shift is at 1. So I'm just going to kind of draw that in. There's my vertical shift at 1. My amplitude is 3. So I'm going to go up 1, 2, 3 above that, and 1, 2, 3 below that. Now, what we want to pay attention to is that when I'm doing this, I have to have 5 marks. So this is going to be mark 1. This is a second mark. This one's in the middle, and then I'm going to have here and here. Okay, those are the marks that I'm going to be doing. Now, since this is a -3, that means instead of me starting at -1, 0, 1, I'm going to be doing the opposite. So I am going to be starting up here, then here, then here. And there's my graph. On number 7, again for this, when I'm thinking about this, I am thinking about it in terms of x over y. So here to here, from 0 radians to pi radians, and then that's my 1, that's my 0, that's my -1. So when I see that I have a 1/3 pi, I mean 1/3 times x, I am going to take 1/3 x and set equal to 0, which means x is 0. And I'm going to take 1/3 x and set equal to pi, which means I end up with 3 pi. So I am going to have an asymptote here at 0 and at 3 pi. So this one's x equals 0. This one is x equals 3 pi. Now for this, my vertical shift is at 1. So I'm going to be up here at 1. That's going to be like where my zeros are. I have a 1/2 as an amplitude, which means I'm going to go up a half and down a half. And so when I'm graphing this, let me just kind of make sure we all know where we're graphing. I mean, I have this point, this point. Now I need to have 5 points. So I am going to go halfway, which is here. So I've got, and then halfway between that. So let's see, 1, 2, 3, 4, 5, 6. So I'm going to have 3 and 3. I'm just spacing it out. So this is where I'm going to be graphing it. And so when I am plotting my point, again, this is a cotangent, which should be starting at our 1, then 0, and then -1. Okay. So my 1 is going to be here at this 1.5, really. This is my 0. And this would be like my -1. And that is our graph. For number 8, this is a tangent again. Okay, and again, tangent, we're thinking y over x. So again, I'm focusing on here to here. So basically -pi/2 to +pi/2. And then this is my -1, my 0, my 1. Okay, that's kind of what I'm thinking. Now, this one has a shift, a phase shift. So what I'm going to do is I'm going to take my x, minus pi force and set it equal to a -pi/2. So I am going to get x is equal to pi force minus pi/2. And that is going to be, let me make it a little thinner here. That is going to be a pi/2 minus 2 pi, a pi force minus 2 pi force, which is going to be a negative pi force. And then I'm going to take this and set it equal to a positive pi/2. And so that is going to be x is equal to pi force plus pi/2. So pi force plus 3 pi, sorry, pi force plus 2 pi force, which is 3 pi force. So this is split into force. So this is going to be pi force This is going to be 3, I'm starting at negative pi force, I apologize. So we're starting at negative pi force to 3 pi force is what we're graphing here. And so when I'm doing this, my asymptote is right here. And here. So the equations for this is x is equal to negative pi force, and this is going to be x is equal to 3 pi force. And I need 1, 2, 3 marks, so I've got those. My vertical shift is up or down at -1. Then I'm going to go 4, 1, 2, 3, 4 above. So 1, 2, 3, 4 above. And 1, 2, 3, 4 below. Now this has a negative in front of it, so it's going to flip. So I normally start at the negative one. I'm going to start at the positive one. So I'm going to start here, then here, then here. And there is our graph. Number 9. For this one, it is a cotangent. And when I'm thinking of a cotangent, again, I know I'm drawing this over and over, okay, but it just wants to visualize that this is going to be x over y. And that means my y is 0 here and here. So I'm going to go from 0 to pi. And then I'm going to plot the 1, the 0, the -1. Okay, now for this one, I have this. So I'm going to take x plus pi and set it equal to 0, which is going to give me x is equal to negative pi. I'm going to take x plus pi and set it equal to pi. And when I do that and I subtract, I'm going to get x is equal to 0. So for this, I am going to have at negative pi, and I'm going to have at 0. Now I do have a vertical shift at -3, so we're going to drop down here. I am going to be going up 1 and down 1. This is a negative cotangent, so I am going to be flipping it. So instead of thinking of it starting at 1, I'm going to think of it starting at the -1. So I am going to be starting at -1, then 0, then 1. And then I have that. Now for the next one, this is, again, a cotangent. So again, we're thinking x over y. So I'm going to have here and here. And then this is 1, this is 0, this is -1. So in this case, we're not shifting it at all. So my asymptotes are going to stay at 0 and at pi. Now I am going to have a vertical shift down to a -1. And then I'm going to go 1/3 above that and 1/3 below that. So this is actually going to be 1/3 because they're splitting the 1 into 3 equal pieces. And since it is a negative, instead of starting at my 1, I'm going to start at my negative 1. So I'm going to start at my negative 1, then 0, then my 1. And there's my cotangent. 11 is a tangent. And so again, this is y over x. So I'm going to be thinking of it from here to here, from negative pi halves to positive pi halves, negative 1, 0, 1. So when we have all this stuff going on here, all of this is going to be affecting where my asymptote is. So I am going to have 1/2 times x plus pi thirds is equal to a negative pi halves. So I am going to multiply by 2, and I'm going to get a negative pi. I am going to be minusing pi thirds, and I am going to end up with x is equal to a negative 4 pi thirds. Then for the other one, I am going to be taking my going to draw it in a different color. Say I do it in purple. I'm going to do it over here. I'm going to be taking my 1/2 times x plus pi thirds, and this time I'm setting it equal to a positive pi halves. So for that, I'm going to have x plus pi thirds is equal to pi. So when I minus pi thirds from both sides, I'm going to get 2 pi thirds. So I'm going to have an asymptote at negative 4 pi thirds, which is not on this graph. And then I'm going to have one at 2 pi thirds. So 2 pi thirds is here. Let's see, did I do my math right here? Negative pi minusing a pi third, so that's a 3 pi thirds. Yeah, I get a negative 4 pi thirds. So negative 4 pi thirds would be, if I draw it, would be over here. So this is going to be x is equal to negative 4 pi thirds. This is going to be x is equal to 2 pi thirds. Okay, and if I go halfway in between, let's see, I've got 1, 2, 3, 4, 5, 6. So this is going to be half. And then halfway in between here, I've got 1, 2, 3, 1, 2, 3. So that's going to be like here and here. That's where we're going to be having our other points. So in this case, we do not have a vertical shift, so that's going to be here. We have an amplitude of 2, which means we're going to be going 2 above and 2 below. My tangent is positive, so I am going to be starting at my negative 1. So this one's going to be here, then here, then here. And when I connect it, there's our graph. Now these ones we want to write an equation. So first thing I'm going to do is just draw in my asymptotes. Just looks like I have one here, here. So as I'm looking at this, This is going to be, let's see, they're splitting this into 1, 2, 3, 4 into 4. So this is going to be x is equal to negative pi fourths. And then we went 1, 2, 3, 4. And so this one's at 3. So this is going to be x is equal to 3 pi fourths. So the period here from here to here is going to be pi. But we did have a shift. Okay, we did have a shift. So for that, so remember that as a tangent, I should normally be here at negative pi halves to positive pi halves. So this is a negative pi halves, okay? We shifted it over by basically by a pi fourth, basically, okay? So this equation is going to be y equal tangent. I don't have a b, x minus pi fourths. Now I do have a shift up. My shift is going to be right here. Oops. This is going to be my vertical shift right here at 1, because then you'll see that here and here we'll have these points. So this is my 0, this would be my -1, and this would be my 1. So I need to add on to this plus 1. On number 13. So for this one, again, let me just draw in my asymptotes here. So it looks like I have one here at pi, at 0, at pi, at 2 pi, okay? So I, right now, without having to shift anything, I can think of this as a cotangent, because a cotangent remember goes from 0 to pi. Now, normally my cotangent, I've got a 1, a 0, and a -1. So this is going to be a negative cotangent. Okay. Now I also got to find where that 0 and those nice values are. So it looks like I have a nice value here that's in the middle, then here, then here. So let's look at those values and see where those are. So for this one, this is going to be a shift down 2, so -2. And then we went up 1, 2, 3 above and 1, 2, 3 below. So my equation for this, y is going to equal negative, because my cotangent should have started at my, actually it did start at my 1, so it is a cotangent, not going to be negative. And my amplitude has changed, it's a 3. My period has not changed, so it's going to be cotangent. I haven't shifted it, but in terms of horizontal shift, I did shift it down 2, so -2. And that's going to be our equation. On 14, again, let me just kind of find my asymptotes here. So it looks like I have one here. It looks like I have one here. And here. So looking at these, it looks like each of these marks is pi, 2 pi, 3 pi, 4 pi. So I'm going by pi's. Each mark is a pi. So this is going to be at 2 pi. This is at 3, 4, 5, 6 pi. This is at -2 pi. So basically my period is 4 pi. So going between any of these, that is a 4 pi. Now, normally it should be a pi. So when I take pi divided by 2 is equal to 4 pi, and I work that out, I'm going to get that my b is 1/4 when I do that math. Okay. Now, looking at this, since I am going to be looking at this being a positive, so I can do this either as a tangent and a cotangent for all of these. But if I'm looking at this in terms of the points that I want to focus on, I have, this is like my 0, then here and here. Okay. So what that's telling me is that my vertical shift is just at 0. My amplitude is going to be 1 because I'm going 1 above and 1 below. What is going to be changing is my period. So again, when I'm dealing with a cotangent, I am starting at my 0, going to pi, and then I have my 1, 0, -1. Now, normally these are going from 0 to pi and has a length of pi, so that has been adjusted. Now, I should normally have had my asymptote at x equals 0. So that has been a shift of pi halves. So I shifted it backwards pi halves. So what I can do for this is my equation is going to be y equal cotangent 1/4, that's going to be my b. And then I'm going to have x plus 2 pi to shift my normal x equals 0 over to the left 2 pi. And that is going to be an equation. Now, I could also, okay, so that's a picture of it right there, okay? But I could have also, since my tangent is on either side of the x-axis here, basically at pi halves and negative pi halves and positive pi halves, I could have just thought of it as a tangent, but a negative tangent. And when I graph this, there you go, you can see that it actually ended up on top of it. Okay. So I could have also just did a negative tangent of 1/4 and flipped it if I wanted to. So just like with our sine and cosine graphs, we could have different versions of these depending on where we're focusing on our start and whether we're going to be thinking of it as a positive cotangent or a negative tangent or vice versa. Okay, so on this one we have negative pi halves, 0, pi halves, and so forth. Okay, so this is negative pi halves, 0. So basically our period is pi halves. So if our period is pi halves, again, normally our period is pi, but if it's not, it's pi divided by b. And so if our period is pi halves, that means our b is 2. Okay, our b is 2. Now, if I'm trying to figure out where my vertical shift is, it looks like this is my vertical shift here at -2. Let me just make that a little bit more transparent. Okay, And then it looks like so let me just kind of plot my points here. So let me just focus here. So I've got a point here. This is one above, that's one below. So I'm really going to be shifting it just like normal, up one, down one. So the amplitude is going to be maybe negative, but basically a 1. Okay, so if I am doing this, one way to think about it is if I am thinking of it as a cotangent. I know this may not normally be a cotangent because it's starting at, actually it is because it's starting at a positive and going to the negative, sorry. So normally it should start here at 0 and end here at pi, okay? And then here's my 1, my 0, my -1. Now, we are starting at our 0, but we are going to pi halves, okay? So my phase shift is okay. The issue is my period, and that's going to be taken care of with this. So our equation is going to be y equal. I'm going to keep it as a cotangent, a positive cotangent. My b is 2. I'm not shifting it left or right. I am dropping this down, okay, to a -2. So I'm going to think about number 16 as a tangent because I'm starting from the negative to the positive, okay? So for this, let's first focus on our asymptotes. The asymptotes here are at 0 and at 3 pi. So I've got x equals 0 and I have x equals 3 pi. Now that tells me a couple things. For number one, it tells me that the period from here to here is 3 pi. Now, normally it should be pi. So if I take pi divided by b and set it equal to 3 pi and solve, I am going to get that my b is 1/3. Okay. Second thing I know is that when I'm doing a normal tangent, I normally should have it at a -pi halves, and it's not. So that means I'm going to have a shift, and I'll talk about that in a second. Now, when I'm looking at the graph, halfway in between these, okay, so that's going to be right here, 1.5 or 3 pi halves. That's where my center is. So let me just put a dot right there, okay? And then if I go halfway in between that, which is right here, I have a point here. And then if I go halfway in between these, I have a point here. So that's going to be showing me my amplitude, okay? Because this is where my vertical shift is, which is, and let me do it in a thinner pen. This is where my vertical shift is right here, okay? Which means no vertical shift. And this is my, where I moved up 2 and I moved down 2. So my amplitude is going to be 2, okay? So far what I know is I know that it's going to be y is equal to 2 tangent. Now I have a 1/3. So, and I don't have a vertical shift up or down, but I have a 1/3 for my b. So a couple ways you can think about doing this is if you want to think about where should you have, how did you move from where you should have been? My asymptote should have been at a -pi halves. It is at 0. So how much was it shifted? It was shifted. I need to shift it. Okay. It was shifted to the right pi halves. So if I'm going to think about it in that sense, then I'm going to put this. This would basically just be my 1/3 x. That would just have changed my period. Okay. From where I normally should have been. But I'm shifting it. And if I'm thinking about the shift of the asymptote and I want it to shift basically to the right pi halves, then I'm shifting it to the right pi halves like this. So let me just show us on the graph. So I have my asymptotes drawn in here. I'm going to go y is equal to 2 tangent, and then I'm going to go parentheses just because otherwise my 3 ends up dividing my whole tangent. Get out of that x. So that's where I would have been. Okay, but again, I want not my asymptote to be over here. I need to shift it. So we were going to shift it to the right pi halves. So I'm going to go minus pi halves, and you see that shifted it. Okay. Now this is where my 1/3 is in my parenthesis. I can also think about it this way. Let me copy this for a second. Undo that one. Okay, so we had our 1/3. Now, instead of thinking about the asymptote, I'm thinking about this point here. This point here needs to be moved to the center of this, which is 3 pi halves. So if I'm going to do it that way, and I'm thinking about not my asymptotes being shifted, but that particular y-intercept there, that point, I can go, and I want to move it to the right, so I'm going to go minus 3 pi, let me spell pi properly, 3 pi halves. And you can see that that ended up in the same spot. So here's my green one, here's my purple one. They are the same. So let me just copy this real quick. So I just copied it from the thing. So again, this one here, which was the first one that I typed in right here. When I was doing this, I was thinking, okay, my asymptote should have been, this asymptote should have been, that one right there. That asymptote should have been at negative pi halves. It got shifted to the right pi halves. So I shifted it to the right pi halves with this minus pi halves. You can also think about this point right here. Okay, this particular point right here. When I was doing that on the graph, it ended up having to be shifted because it was actually on my y-axis, but it should not be on my y-axis. It should be here. Okay, so it was on my y-axis normally. I needed it shifted here. That's where my 0 is. And so I needed to move it to a 3 pi halves. I needed to move it right 3 pi halves, and I did that here. So either one of these two equations is acceptable. Okay, it just depends on if I want the 1/3 in or the 1/3 out. Okay, on number 17. So for this one, again, I'm going to think of this as a tangent. Now looking at this, this is negative pi halves and pi halves. So so I'm splitting that into thirds. So pi 6, 2 pi 6, 3 pi 6. So since I'm splitting I'm splitting pi halves units into threes, I'm splitting this into threes. Okay, I'm taking a third of it. These are each going to be a pi 6. So this is going to be at a negative pi 6. This is going to be at, okay, so I'm going to be pi 6 off of this. So this is going to be at 5 pi 6. So the distance from here to here will be my period, and that is going to be pi. Okay, that is pi. So my b, I don't have a b. So in this situation here, if I'm trying to find my point that's halfway in between here, okay, halfway in between here is going to be this one here, and then halfway in between here, okay, that is going to be if I'm looking at it, let's see, 1, 2, 3. So here it's going to be there. And here between these 1, 2, 3. So here I'm going down. It's going to be here. So that one, those ones weren't in the nice spot, but again, you're looking halfway in between your asymptote to get your middle, and then halfway in between the middle and the asymptote to get the next point. So if I sketch this in, my vertical shift is right there. My normal ones are going to be up here, and my normal negative ones are going to be here. Now, let's see how they're scaling this. Is it by ones? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it is by ones. So this is going to be at a -2. This is going to be at a 1. Then this is going to be at a 4. So my amplitude is going to be a 3. So this is going to be y is equal to 3. Tangent. I do not have a period change, okay? I do have a phase shift, however. So I want to figure out, I should have had my asymptote at a negative, let me just, here, get rid of that. I should have had my asymptote at a negative pi halves. It was shifted to a negative pi 6. So how far did I move it? Well, if I try to get this to be a common denominator, this is going to end up being a negative 3 pi 6. And then I shifted it to a negative pi 6. So I basically needed to, I went to the right 2 pi 6, which is the same as pi thirds. So I'm shifting it to the right pi thirds. So what I can do is I can come up here and go x, because again, there's no b. My b is, well, I shouldn't say there's no b. My b is a 1. And then I'm going to shift it to the right pi thirds. And if I put this into the calculator, Desmos I meant, okay. Here's my asymptotes, negative pi 6 and positive 5 pi 6. And I'm putting in y is equal to 3. And let's see, did I have a shift up or down? Oh, I did, sorry, I did have a shift up, forgot my shift up, because it's here at 1. So I'm going to go +1, okay. I thought I had a shift. Okay, so cotangent of x minus pi thirds, okay, and then +1. Oh, wait, I haven't, did I change? I've got my asymptotes here. Oh, it's not cotangent, sorry, it's a tangent. I apologize. It's a tangent, okay? Now, if I wanted to double check some of these values here, I want to double check the height at 4, the height at 1, the height at -2, just to make sure you're on the right track. You can always do that. Just put in y equal 4, y equal 1, y equal -2. Okay, I know I got a lot of lines here, but I'm focusing on these particular ones. So here, this is at pi thirds, comma 1. And this is going to be, we're basically going by pi 6 here, right? So in terms of this point right here, this is going to be, so sorry, which point am I looking at? If I'm looking at my y equal 1. So again, these are, I have pi halves split into thirds, which makes them each a pi 6. So this point right here, okay, let me get my, this point right here is at pi 6, 2 pi 6. So this is pi thirds, okay? This point right here is going to be halfway between here. Okay, so that's going to be a pi 12ths. And this one here, okay, so this is a halfway between, let's say, 3 pi 6 and 4 pi 6. So halfway in between there, that is going to be 7/12. And if I come here and I look at this graph, just as a double check, you don't have to do this. This one down here is at pi 12ths. This one here is at 1. Pi thirds is at 1. And 7 pi 12ths is at 4. That's just a way to double check yourself. So my final equation is y is equal to 3 tangent x minus pi thirds plus 1.